Okay, so let us start. Okay, so we were actually proving the proposition. So we stated the proposition, so let us write its proof. So now proof of the proposition. Now suppose P satisfies the defining relations in rho. P satisfies the defining relations in rho. Relations in rho. Okay, with respect to phi. With respect to phi from A to T. Then then we have this. So we have this rho is a subset of kernel of phi plus. Rho is a subset of kernel of phi plus. Since kernel of phi plus is a congruence, we know this. Since kernel of phi plus is a congruence on A plus, and here we get that rho is contained in kernel of phi plus, means kernel of phi plus is a congruence on A plus containing rho, but rho sharp is the smallest congruence containing rho. And rho sharp is the smallest congruence on A plus containing rho. So this rho sharp is contained in kernel of phi plus. Rho sharp is a subset of kernel of phi plus. Okay. So the map psi from A plus our rho sharp to T defined by this say U rho sharp of psi equal to U phi plus is well defined homomorphism and is clearly surjective. Is well defined homomorphism and clearly surjective. Clearly subjective. It is surjective because phi plus is surjective, as phi plus is surjective. And well definedness follows from this fact. How? Because if you take rho, so well defined means what? You take two elements as same and you see their images are also same. So well defined means if you take u rho sharp equal to v rho sharp, it means u and v, this pair belongs to rho sharp, but rho sharp is contained in kernel of phi plus. So this means you have u phi plus is same as p phi plus, and this is what your u rho sharp psi is. So u rho sharp psi is same as v rho sharp psi. So this map psi, it is well defined. It is a homomorphism because phi plus is a homomorphism. Again, it is surjective as phi plus is surjective. So you get the required result. now now let suppose you have two words uv in a plus. So if there is a sequence, if there is a sequence of elementary row transitions, this we have already defined, this concept of elementary row transitions. So if there is a sequence of elementary row transitions, so u equal to say w0 goes to w1 goes to so on goes to wn equal to v. So this is a sequence of elementary row transitions. Then we say that this pair u comma v is a consequence of row. We say that हाँ बैकग्राउंड में किसी की आवाज डिस्टर्ब कर रही है भाई, आप म्यूट करो. We say that this pair u comma v is a consequence of row, or u comma v can be deduced from row. U can be deduced from v by row, or u can be deduced from v by row. Actually, what we are doing here, you have any two words here and you say that u comma v, they are in this congruence. By definition of this congruence, either u is same as v or you have a sequence of transitions of this type connecting u to v. So what you say here, if you have a transition of this type, you say that uv is a consequence of row, or you say that u can be deduced from v by row via this sequence of elementary transitions. Okay, the next result actually says that there is a connection between this u can be deduced from v by row and semigroup presentations, because all we have is actually that if S is presented by this presentation, then by definition S is isomorphic to A plus our row sharp. So you have to deal with these type of situations here, because if you have any two elements S1 and S2 here, they correspond to the classes. So S1 will correspond to here say U row sharp. S2 will correspond to V row sharp. Okay, so all you have to have is that this UV actually belong to row sharp, and you have a situation of this type. So the next result says that there is a connection between these two things. So we have actually a proposition which says that, so let S be presented by the presentation a row, and let uv, they are two words in a plus, then u is equal in s to v. This we have already defined. If and only if and only if this pair u comma v is a consequence of a row, is a consequence of row, that is, if and only if you have a sequence of elementary transitions connecting u to v, elementary row transitions. So there is a sequence of elementary row transitions u equal to w0. So here either either w1 is connected to w0 or w0 is connected to w1. I am writing arrow both sides. So on wn, and this is v. Now let us see how it is true. So notice that u is equal to v in S. If and only if u comma v belongs to row sharp. And row sharp, we know that it is row CE. So, thus, so you can say that this is if and only if u comma v belongs to now this row CE, we know its definition. Its definition is what? Row C union row C inverse union identity on A plus infinity, power infinity. Or you can say that this is if and only if uv belongs to union and running from 1 to infinity row C union row C inverse union identity on A plus power n. Okay, so it means that it belongs to this for some n, or you can say that this uv belong to row C, this is if and only if union row C inverse union identity on A plus power n for some positive integer n. And we have already seen that when you have this situation, it means that, so this is if and only if there exists n in n and w0, w1, so on, wn in a plus such that u is equal to w0, v is equal to wn, and for all I wi comma wi plus 1 belongs to row C, or wi plus 1 comma wi belongs to row C. So what we what we conclude is that, so hence u is equal to v in S if and only if there is a sequence, there is a sequence and there is a sequence, there is, so if and only if there is w0, so on wn in a plus with w0 is equal to u, wn is equal to v, and either wi goes to wi plus 1 or wi plus 1 goes to wi, or you also have this situation because we have actually we also have to include this case, or wi is same as wi plus 1 for I running from 0 up to n minus 1. Now, if this situation happens, then we can shorten the sequence. If you have two consecutive steps where wi is same as wi plus 1, so you can just reduce the length of the sequence and you get a sequence. So, since I think we have done it when we were studying this, the characterization of this row sharp, but just I am doing here, since we can shorten the sequence by removing any steps, shorten the sequence by removing any steps where you have this situation that wi is same as wi plus 1. So we get that u is equal to v in S if and only if you have this situation, you have this situation, and this is nothing but what we claim that we have this thing. So this is actually the sequence of elementary row transitions if and only if there is such a sequence consisting entirely of elementary row transitions. There is such a sequence consisting entirely of elementary row transitions, and this proves this theorem. So I think it is enough for today. If you have questions, please ask questions. Any question, please? So if there are no questions, then we will end this lecture. Who is CR? CR कौन है आपका भाई?
सर उसने ज्वाइन नहीं किया सर, उसका रिचार्ज खत्म हो गया था।
हाँ, जो इसका ना अटेंडेंस का एक स्क्रीनशॉट लेके मुझे सेंड करो, ठीक है?
ओके सर।
ओके, सो वी विल जॉइन टुमारो इंशाल्लाह। ओके, वी आप ले लो, फिर मैं एंड करता हूँ इसको, है? लिया आपने भाई?
Yes,
ओके, सो लेट अस स्टॉप।